Are we on? Yes, using the amazing on switch, these things work. That's awesome. Howdy. I'm Jeffrey Snover, Technical Fellow and Chief Architect for the Azure Storage Media and Cloud Edge team. And today I'm here joined by Natalia and Dean, and we are going to tell you about the intelligent edge and how we're delivering that with Azure Stack and Databox. Okay, so let's first try to get this edge in perspective, right? So presumably everybody heard about, Satya talks a lot about the intelligent cloud, intelligent edge. And sometimes when I hear these things, it's like, what does that actually mean? And is it real? And how do I use it? And how do I think about it, et cetera? So that's what the goal of this first section is to get what is this intelligent edge? What is it really? And what is it used for? How do I use it? How do I think about it? Because what I hope to convince you is that the intelligent edge really is a new era of computing. And then talk about, well, what does that really mean? And how do I think about that? Okay, so when we think about something, we want to first evaluate it based upon what is its purpose, okay? So imagine the case, a couple years ago I bought a car. Actually, last year I bought a car. And so as I was out evaluating which car I should buy, I was thinking, well, how am I going to use it, right? Well, I use it to go back and forth to work. I take small trips, et cetera. And so when you evaluate a car, you evaluate it against its purpose. So I was looking at things like how much did it cost? What is its safety rating? What is its miles per gallon? Do I look cool in it? That sort of thing, right? But that's great for evaluating a consumer grade car. But there are other vehicles like a bulldozer or earth mover. I'll just go with bulldozer. There are other things like bulldozers where those ratings would not be the things you'd use to choose a bulldozer, right? You wouldn't say, oh, I'll buy this bulldozer over that bulldozer because it has better miles per gallon, right? You say, well, what the purpose of this thing is different than the purpose of a car, even though they're both vehicles. And so for a bulldozer, you'd be interested in, well, what's the duty cycle of that? How much land can I move per bucket? How big is the bucket, et cetera? So the point I want to make is when you think about a system, you think about its purpose. And I teed up that whole conversation to do a little magic, a little hand trick on you, and that is this. Okay, so in the past, you might have heard of, we talk about the eras of computing, and we would talk about, well, the mainframe era. And the mainframe era was replaced by what? The client-server era. And the client-server era was replaced by what? Or really, these things never get replaced, they get augmented. So be clear on that, they never get replaced, they get augmented. The client-server era was augmented with the cloud era, okay? And that's great, right? That's the common way of thinking about it. But I'm going to say, you could just say, oh, and now the cloud era is going to be augmented with the intelligent cloud, intelligent edge. But when you talk about it that way, it doesn't really elucidate anything. It doesn't help me think, what is this for? Why would I do it? Should I do it tomorrow? Should I do it next year? Should I ignore it, et cetera? And by shifting to purpose, I think things get a little clearer. So let's talk about purpose. There are systems of record, systems of communication, and systems of engagement. And guess what? These things roughly map to mainframe era, client-server era, cloud era. But examples of these things, mainframe for systems of record, are things like Sabre. Sabre is the thing that runs all the airline ticketing. Built a long time ago, sort of the classic system of record. When we talk about communication, it's things like SharePoint, Active Directory, Exchange, and then examples of engagement would be things like Bing, Amazon, Facebook. Now, to tee that up, let's think about those things, those purposes, and how that translates to a number of different characteristics, okay? So, for example, systems of record, what should they be? Like, what is a good system of record versus a bad system of record, right? And the answer is systems of record, they need to be accurate. like super, super accurate, right? I'm going to charge you money, I'm going to put you in an airplane, I'm going to schedule an airplane. These things need to be accurate. They're systems of record, okay? How do you measure these things? Miles per gallon, bucket size? No. You measure them in terms of transactions. How many transactions can I do per second? By the way, there's a fun thing if you actually go look at Sabre systems. Apparently, they don't have any error handling because they need to have very, very high transaction per second. And dealing with errors or trying to deal with errors cleverly reduces the transaction count. And there's a great story about that in a book called The Psychology of Computer History, I believe. A great story about that. So the mature state of systems of records are these things, these dedicated facilities, right? The mainframe, the little altar where you sacrifice the chicken, just well-defined, the big glass plane. And the dominant architecture, of course, is mainframes, the big iron. Now, here's an interesting way to think about things, and I really want to hone in on this line. What's the business model, right? Because you're going to find that these things, right, whenever you think, well, mainframe, client, server, cloud, do you think business model? I never do. But when you pivot and you think about purpose, all of a sudden you're going to see this kind of highlight. So what is the business model for a mainframe? And you see it's a contract, right? There's a well-defined contract between the consumer and the supplier of these things, okay? And often it's a very long, multi-year contract with very very formal thing. And of course, the operation model is custom, right? It's whatever it takes to run that record. Now, some of this might be a little vague. Let's get to a couple more columns, and I think you'll find it all come into focus. And then these things help us understand what this new intelligent cloud, intelligent edge is. So, communications. Examples of these are things like SharePoint and Exchange. What should they be? Accessible. Whole point about communications is communicating. Okay, so it's got to be accessible. It's got to be everywhere. It's got to be on a PC. It's got to be on a Mac. It's got to be on a phone. It's got to be everywhere. So these things have to be accessible. How do you measure communication systems? IOs, messages per second, etc. What is the mature state? And that is PCs, or really it's kind of client devices, be it a PC or a phone, but client devices, and then data centers. What was the enabling technology? So really, you couldn't have done this technology without microprocessors and networking. And what is the dominant architecture? That is client-server. And what is the business model? Now here again, it gets interesting. You shifted from a custom contract to a license. You buy the software, right? You buy a license. You buy a license to Exchange, you buy a license to SharePoint, etc. So you have a license. The operational model is IT service management. So now let's talk about systems of engagement, sort of the more modern stuff, the thing we would categorize in cloud, the cloud era. And examples of these would be like Bing and Amazon. And what should they be? So systems of record need to be accurate. Systems of communication need to be accessible. Systems of engagement need to be attentive, right? They're all about your attention. That's what they optimize everything around, is your attention, okay? And why? And we'll get to the answer, the business model. It's all around your attention, okay? So how do you measure these things? And the answer is release velocity. How quickly can they release things? How quickly can they get an insight and release something? Turns out people are searching on a particular term. How quickly can we refresh and get great information about that term? Okay, quickly. Though the mature state of this is mobile systems and the cloud architectures. The dominant architecture, microservices. Microservices everywhere. And here's the business model. Business model for these attentive systems, and why attention is why they need to be, is because they are all about selling you things or selling you. Selling you or selling you things. Selling you, it's your attention. You pay attention to some page, and I sell that attention to some advertiser because he's going to put your ad there. Or I'm going to give you a page and you're going to buy something. Oh, that looks like a great toaster. Buy that toaster. Okay? That's what they're all optimized around. And the operational model for this is, of course, DevOps. Okay? So you'll see that pivot, I think, is a little more useful, and especially now as we talk about the next era. Next era is systems of amplification. Systems of amplification. So systems of amplification should be things that enhance what people can accomplish, and they do so by incorporating IoT and AI. Okay? And what they provide are going to be real-time, contextual, and adaptive experiences. Boy, did any bingos out there? Any buzzword bingos? Come on, somebody should have won on that one. Lots of buzzwords, but each one of them really means something. And you'll see that's the point of the presentation, is to say, great buzzwords, what the heck do those things mean? It's all around this idea of amplification. By the way, let me be clear. Don't Google this. Don't Bing this. You're not going to find this. There's not some big Microsoft program to roll out the idea of systems of amplification. One of my jobs as a technical fellow is to kind of look at things. It's my strength and my weakness. My weakness is I can't deal with complexity. My strength is I look at all this mess, and when it confuses me, I say, what the heck's really going on here? What's the heart of it? What's the heart of it? And then when you understand the heart of it, my background is in physics, right? When you understand that F equals ma, then you're like, okay, now I understand it. Now all this complexity makes sense. This is what matters. And then from there, I understand this matters, that doesn't. I should do this, I shouldn't do that. So that's what I've done here, is to think through what's really going on with this intelligent cloud, intelligent edge. It really is about the system of amplification, and I think you'll see it be picked up later on, but really you're hearing new stuff. Okay. So when I talk about systems of amplification, what should they be? They need to be appropriate. Appropriate. What the heck's appropriate? Think through precision agriculture, right? Precision agriculture. The point there is not, hey, I've got these crops, go put this much water on all those crops. Put this amount of fertilizer on all the crops. Rather, it is, I need to be appropriate. I want to understand the state of my crops, state of the soil, state of the progress, and do the appropriate actions. Apply the appropriate amount of fertilizer. Apply the appropriate amount of water. Harvest it at the appropriate time. This is very different than the sort of manufacturing approach of like treat everything the same. So these systems need to be appropriate. Now, how do you measure these things? And the answer is insights. Now, honestly, this is a new era, so I don't really know how to measure insights. Insights per second. I don't know what that looks like. But it is what matters here is insights. And I will tell you that there are two flavors of insights. One flavor of insight is the thing we've talked a lot about. Hey, with big data and visualization and business analytics, we can help you gain insights. So these are human insights. But I'll tell you that there are also artificial insights. Artificial insights. Artificial intelligence can help find correlations and thus insights that you can never find. Okay? So it is how do we create and leverage both human and artificial insights? The mature state of this will be the intelligent cloud. In fact, the intelligent cloud, intelligent edge. You should always think of those two things as being one, okay? There is no such thing in my mind as the intelligent edge without the intelligent cloud. That would just be the edge, and that would be the dumb edge, right? The whole point is that in my mind, this intelligent cloud, intelligent edge is about the edge being better because of the cloud, and the cloud being better because of the edge. And hopefully I'll make that case for you. These things are always viewed together. The instigating technology, what enables this to happen is this IoT and artificial intelligence. The dominant architecture, TBD. TBD. Guys like Dean, me, Natalia, we're figuring this out, right? Parts of the picture we understand pretty darn well. Parts of it, I think you're going to see emerge. The part that we understand very well is full stop, you are going to have integrated fleet and application management, and you're going to have a range of Azure services available everywhere. The part that we're going to figure out is the various application models. What is the code that takes advantage of those application services? And there I think you'll see a number of things that will be contenders, and I think over the next 5 years you'll see new application models. Whatever the application model is, it will still be using Azure services. Microservices are critical in this area. But for instance, right now, Service Fabric, Kubernetes, very hot, very exciting. Great stuff, great stuff. But I'd be surprised if they were the great stuff 5 years from now. They might be, but I'm open to the case that they're not. Beware, whether it was the shift from mainframe to client server or client server to cloud, if you recall, these transitions, the transitions take like about 10 years. They really do. This might happen a little bit sooner, but it could be 10 years. So you'll hear about it, you'll say hype, hype, hype. 3 years from now, you'll say, oh, that stuff never panned out. 5 years from now, it's like, hey, how come nobody's hiring me anymore? Unless I put Intelligent Cloud, Intelligent Edge on my resume. That's the way these things work. And the operational model, DevOps plus, plus, plus. DevOps is critical. DevOps is critical for the way we do things now. DevOps is critical for this, and you're going to see changes are required to be successful for it. So these systems of amplification, they have the following characteristics. They are intelligent, okay? Something keeps beeping. They are tactile. They interact with the real world, okay? They are real-time and near real-time. They are distributed and variably connected. Some of these things will be constantly connected, but when you're constantly connected to the cloud, the answer is sometimes you're constantly connected. Sometimes things go wrong, connections break, etc. There will be other scenarios, submarines, cruise ships, etc., or just because, where they will be disconnected. They need to work there. And key to this is they need to work with chaos. They need to work with chaos. It's hard to underscore how important this is, and it's how easy it will be to not pay attention to this and produce a system which will cause harm. So let's connect those dots. We've got intelligent systems which are tactile, that are modifying, managing, monitoring, and changing the real world. And if they don't deal with chaos, oh, I got disconnected. Oh, I got some input I didn't expect. Oh, something went wrong. If they cannot do that and continue to appropriately manage the physical world, serious harm could come about. So these systems have to not just be smart about, gaining some insight. They need to be smart about what to do when things go wrong. Now, William Gibson said, the future is already here. It's not just evenly distributed. You might be thinking about this and saying, I don't know, maybe, sounds like rocket science, sounds like science fiction to me. Here's a piece of data. General Electric has been doing this for over 20 years. General Electric, over 20 years ago, hired a bunch of data scientists. They had real-time telemetry of their aircraft engines, and they would take that, analyze things, and over 20 years ago, they were able to correlate, hey, when we see these parameters change in this way, it means this part is going to be needed to be replaced within this time period. And what they would do is they could tell that while the plane was up in the air, and they would see where the plane was going because they did all the servicing. Where's that plane going? Is that part in that location? If the answer is true, then they would say, great, we're going to reschedule so that when that plane lands, he goes to the maintenance hangar, gets that part replaced. If the part was not there, they'd say, can we get the part there in time? And if the answer was no, they'd say, do we have enough time for the plane to make another flight before it needs to be replaced? And if so, let's move the part to that third location. and get it there for repair. Incredible stuff, like the stuff that talk about appropriate, intelligent, tactile, all that good stuff, done over 20 years ago. So the future is already here. What's going to change is enabling technology is going to make it so that a far larger group of us are able to do this. Okay, so our vision is a platform. Look, Microsoft at the end of the day is a platform company. That is our DNA. We're a platform company. You will hear others mirror our stuff. Microsoft these days is a leader. You know we're a leader because when we talk about something, the other guys follow. It's a nice position to be in. So you will find that they will follow. But what you're going to hear is they will mirror our words, but they will not be delivering the same thing. They will be talking about something else. They will almost certainly be talking about something along the lines of an intelligent cloud, intelligent edge solution or feature. We are a platform. As a platform, we help you be great. We amplify you. We enable you and your organization to achieve more. That's our mission. That's why we build platforms. It's about platforms. So how are we going to do that? We are going to build a standardized AI tool set and training model. We're going to enable a broad ecosystem of IT tools, make sure they adhere to a well-defined set of standards so that you can leverage them with your applications. We're going to produce this ubiquitous cloud platform with integrated fleet and application management, and with a set of uniform Azure services across various modes of computing, and, well, as I mentioned, this management model. So what does success look like? We really believe that there will be new economics. Don't focus on this as, oh, I can save money. This is not a save money play. This is a make money play. This is enable new scenarios. So we can imagine new economics. Here this says reduce TCO. This is an old deck. I hate that term. This is not, in my view, about reducing the cost of ownership. This is about maximizing the benefit of ownership. It's a big difference. The other day I had a conversation with the guy. I said, well, how do you deal with this when people say, well, hey, instead of leveraging someone else to provide some IT service for me, when should I do it? You know, when should I pursue digital transformation versus pursue efficiency? And I said, it's really a question of whether you're trying to save $1 or make $10. Because if you focused in on saving $1, there's only so much money you can save, but there's no limit to the amount of money you can make. And that's where you want your focus to be. So this is about enabling new technologies, enabling new business, and making a lot of money from it. And it's about IoT and the line of businesses working together. Natalia.
Yeah, hand over. So thanks, Jeffrey. I love his mental model on looking at amplification because I think it really resonates. But let's get to where we are today. And Microsoft has a continuum of end-to-end edge capabilities that are available all the way from very small MCU devices where we've got security with Azure Sphere up to the public cloud. So Microsoft, if you look at Intelligent Edge, we've got edge devices that go from MCUs to devices where you can have AI models on things like drones through DataBox Edge, which was announced today, and then to Azure Stack, which is a cloud that you can have on premises. The beauty of part of this edge solution is that you can have everything going publicly to public Azure, or Azure Stack as a cloud can act as a cloud for your end-to-end edge continuum. We have a consistent development paradigm, so you've got tools, consistent security, identity, management, as well as some of the AI, and a very broad and robust ecosystem that's available across this intelligent edge. Azure IoT Edge gives you the capability to do things like have containerized services like cognitive services available to do AI and machine learning at some of those edge devices. And then consistency between Azure services gives you even more capabilities at the cloud level with Azure Stack and Azure. So as you can see, Azure Stack can be that cloud because it is a consistent cloud. So your edge devices can completely connect to Azure Stack in a disconnected environment where you may not have access to the internet. This could also be where you have periodic or intermittent access to the network, but you still want to have a complete edge platform where you can do real-time processing at that edge location. Some of the design principles, Jeffrey's already talked a little bit about some of them, but these are key design principles that we feel are really important at the intelligent edge. Security. As you're starting to have hundreds of thousands or sometimes even billions of devices out there, security is paramount. You want to access insights and data from those devices, but you need the security to be there. Application management or fleet management. You've got many different platform devices where you would have platforms across Azure Stack where you have multiple of those potentially, Data Box Edge, IoT Edge. So you need a consistent way to manage those applications across those. It needs to be cross-platform, continuous and continuously available, as well as extensible. So we've got an ecosystem as well as modular. So these are the key design principles that we look at across the intelligent edge. Now we're going to go into some of those components of that end-to-edge platform, and I'm going to hand over to Dean to start with the sphere and the device ecosystem.
Thank you. Okay. Hi, everybody. So I'm going to take you through the left-hand side of the diagram that Natalia and Jeffrey just put up on the screen. And we're going to start by talking about Azure Sphere. Okay, so quick show of hands. Who's familiar with microcontrollers or MCUs? Okay, good. Up here on the stage for sure. If you're not familiar with what MCUs are from a architectural or a technical perspective, you've almost certainly used one in your day-to-day life. MCUs are single-purpose computing devices that power everything from smart refrigerators to mobile devices to things like industrial IoT equipment, right? So you've certainly used one of these. There's something like 9 billion MCUs created every year. So the number total in the wild is something between 50 and 100 billion. I've heard the number kind of thrown out. Increasingly, MCU devices are getting connected, right? And because they are connected, we really need to start thinking about security for these devices. I don't know if anybody watches the show Silicon Valley, but there's this entire plot line in Silicon Valley where they turn a smart refrigerator network into a distributed storage platform. Right now, I'm not here saying that one day you're going to go to your smart refrigerator and there's going to be a sign on the window that says, hey, I demand a ransomware payment or I'm going to melt your ice cream. But it is something that you need to think about for sure. And Sphere, going to something Jeffrey brought up, is an end-to-end platform by Microsoft for manufacturers to develop secure MCU devices, frankly. And there's 3 basic components to Azure Sphere, and they're actually quite simple. The first is the hardware itself, the Azure Secure MCUs. So we have a certification program and reference designs so that silicon vendors can make MCUs from the ground up that have the latest and greatest security features built directly in from the hardware, right? So that's the foundation. One step up from there, there's the Azure Sphere operating system. That's a Linux-based operating system that runs on these secure hardware platforms. That gives it a best-in-breed security. It gives it a best-in-breed security standpoint end-to-end across the software layer. And then there's the Azure Sphere Security Service. And the Azure Sphere Security Service effectively is a cloud-based service that can make sure that these Sphere devices can stay up to date all the time, basically from the cloud. So you've got a complete platform here, starting with the hardware, the software that runs on top of it, and then the cloud service that keeps everything up to date. And that's the far left-hand side of the spectrum, which is the MCU side. Moving on from there, we're going to talk about Azure IoT Edge. So if you're in an IoT scenario, and you've got, imagine you've got this scenario where you've got, industrial cranes or oil wells or sensors all over the place kind of sending data up to the cloud, you can see that in certain scenarios on the edge, it's not particularly efficient, or I guess appropriate would be the term, for all those individual sensors to send data directly to the cloud itself, right? You can think that if you're at an oil well, you might be in a place where you have limited connectivity, right? Or maybe you do have connectivity, but your bandwidth is really lousy because you're going over something like a satellite connection. In those cases, it's really, really helpful to have a gateway-style device that sits between your IoT devices and the cloud. And that gateway-style device can be used to collect information and to do even smarter things like store and forward that information in the case you have your connectivity coming back, or even process that information. If you want to cleanse the data, make it more hygienic, throw out rote data. In fact, you can get really, really smart at the edge, and you can start to do things like machine learning and inferencing so that when your sensor data comes in, you can start to make really great decisions about that data. So IoT Edge, Azure IoT Edge, is the platform that enables those gateway-style devices out at the edge for all of your other IoT devices to sit behind. And there's a little architecture diagram here on the screen, and I mean, I leveraged my PowerPoint skills to try to build this, but the idea is that you've got all of these sensors out on your individual IoT devices. They feed data into IoT Edge, and then IoT Edge can smartly handle that data before sending it off to the cloud. And really, the way that it does this processing is by providing a platform that is modular, to go back to something we had in the previous slide. And the modules that run on IoT Edge can effectively be custom code that can bring Azure services down to the edge. Microsoft has created some sort of prepackaged modules that do things like machine learning and that do things like stream analytics. There's a module that does SQL. There's a module for Azure Functions. But effectively, any application that you can create or any custom code that you can write that you can containerize, you can actually push down to one of these IoT Edge devices, and you can make that be actionable at the edge. It's really, really, really great platform. It's a really, really great platform, and it's in fact cross-platform as well. You can do Windows, you can do Linux. Okay. The next thing you might be asking is, gee, how do I find IoT devices that work with the Microsoft Azure IoT suite? Well, of course, we have a solution for that. You can go to catalog.azuriotsolutions.com, and on that particular online website, which has been around for about 3 years, so it's fairly mature now, you can find any range of devices that are sort of the leaf node endpoint style devices, moving all the way up to those gateway style devices. So, what I would say is if you're looking for devices that are compatible with Azure IoT, that's a great place to start. Okay. Of course.
Yeah. So, mic on? Yeah. So I mentioned to you that the future is here today. It's just unevenly distributed. As I was reading up on these industrial controllers, et cetera, there are some great standards bodies out there, and one of them is there's a standard called OPC UA, and I said, oh, well, I wonder what OPC is, and anybody know OPC UA? Oh, wow, that's excellent. OPC UA stands for OLE Process Control. I forget what the UA is. But anyway, OLE, if you're an old-time Microsoft person, Microsoft invented OLE in 1990. So in fact, Microsoft has been working with the process control community for a very, very long time. So what was the future was, today's future existed back then. It's just unevenly distributed. I thought that was a fun piece of trivia.
Okay, so one more click stop on the continuum is the DataBox family. Who's been on the show floor? Has folks seen the DataBox hardware on the show floor? Okay, a lot of people have. So DataBoxes are a first-party family of edge appliances from Microsoft. So these are all Microsoft-branded appliances, and there's sort of two broad categories of these devices. The ones on the left-hand side of the screen are the ones that are the transfer via shipping. I mean, literally, these go through the mail. And they are ruggedized devices. You order one from the Microsoft Azure portal. Microsoft sends one to you at your location. You copy all your data onto it, and you send it back to us. They are self-ruggedized. They can ship without any external packaging. On today's talk, we're going to focus on the other side of the spectrum, which is the DataBox Gateway and DataBox Edge side of the slide. And those are online data transfer appliances. Again, same thing. You order one of these from Microsoft. We send it to you. You use it as long as you need it, and you send it back to us. But these focus on the online over-the-network style of data transfer as opposed to the offline over-the-mail style of data transfer. And let's look in particular at DataBox Edge. So DataBox Edge, new offering from Microsoft, announced for the first time at the show. It's in preview now, and it has sort of four major characteristics to it. One, it's a network storage gateway, right? So it can extend Azure storage out to an endpoint at the edge so that your applications and services have a local place to kind of talk to Azure and to read and write data, right? Two, It's a edge computing device, so it extends a compute surface out to the edge so that you can do local computing on the device as well. The platform that it uses for computing is that IoT edge compute platform that I mentioned previously, right? So it's a very streamlined but very rich sort of computing platform that can do any sort of containerized compute application. Databox Edge, if folks have heard of the Project Brainwave FPGA, Databox Edge does ship with the Project Brainwave FPGA, and what that means is that you can accelerate certain types of workloads at the edge, and in particular, machine learning style workloads at the edge. So that's also part of Databox Edge. And then really importantly, it's a Microsoft appliance, not just Microsoft branded, but the entire solution for Databox Edge is offered as a first-party service from Microsoft. And what that means is you don't need to make a capital outlay to get a Databox Edge appliance. We offer the entire Databox Edge solution effectively as an Azure service. So for something like a few $100s a month, you can have one of these appliances on premises. As long as you're using it, and when you're done using it, you can send it back to us. Okay? So I'm going to double click on a couple of these capabilities, and then I have a demo. First, we're going to double click on the network data transfer. Really, this is pretty simple, and this is a capability that is shared by both Databox Edge and the Databox Gateway. Databox Edge, by the way, is the physical appliance. There is one of them up here on stage if folks want to come take a look at it after the talk is over. When you're thinking about the storage transfer, it's just really easy to think about this. Usually, when you're reading and writing to Azure Storage, you've got something local that's like using REST APIs and kind of going over the network and talking directly to the cloud. And that works fine if you've got good network connectivity. With Databox Edge, you can use those same APIs to talk to the Databox Edge device. And the Databox Edge device will give you like a nice local cache to land all those reads and writes, and then it will optimize those reads and writes and trickle them up to the cloud over your network connection. So if you've got an intermittent network connection, no problem, we'll handle that for you. If you've got a very limited bandwidth network connection, no problem, there's a 12 terabyte NVMe cache on that particular device, right? It's a big NVMe cache, it's all NVMe inside this device. And it's a two-way gateway as well, right? So you can have it from the perspective of you put one of those in your data center or on the edge, you write to it, it trickles up to the cloud. You can also make writes in the cloud, and you can trickle those writes on the cloud back down to the device. So it is a true two-way gateway. It presents 3 different types of storage protocols out at the edge. So it'll do not only object-based storage, where you can use the Azure REST APIs to do object-based storage on the device, but it can also do SMB and CIFS and NFS, right? So you can use any of those protocols to read and write to it. And in particular, supporting SMB and NFS means that it just has compatibility with, I don't know, the last 20 years of just sort of traditional enterprise IT applications out at the edge. Really, really simple. Databox Gateway is a virtual machine form factor. And if you want just the storage gateway components, you can actually just get the virtual machine for the Databox Gateway, and you can actually just run that on any piece of hardware you want. Okay? So that's the storage functionality. Next up is the compute functionality, right? And if you saw the IoT Edge slide that I had previously, this is going to look similar, right? So there's a compute platform that runs on Databox Edge. It is the IoT Edge computing platform. As I mentioned before, that IoT Edge computing platform is like super extensible, and you can have lots of different modules that run in it, and you can kind of string them together like a data processing pipeline. There are modules that do machine learning and stream analytics and functions and SQL, and you can write your own custom code and do all these sorts of interesting things with modules. Really, if you can package it up as a container running on either Linux or Windows, you can push it down to Databox Edge, and it can run that on the particular device. But the idea is that data will come in through the storage gateway, and it will flow into this processing pipeline. And then once it's going through the processing pipeline, you can do cool stuff with it. You could run Azure Functions on it, for example, and you could do something like compress an image that's coming in RAW format and move it into a JPEG. Right? Or we have a customer, you can do anything from like really, really simple transformations to do really, really complex things such as machine learning. Okay, but rather than just talking about it, let me actually show you a demo.
Hey, while you're switching to the demo, I noticed a number of people are taking pictures of the screen. If you're doing that and you haven't already got this installed, you definitely need to try out Office Lens. It is a crazy good application on your phone. And you take these kind of weird angle thing and it straightens it out. It is a fantastic, I rarely do this, but it's so good. Office Lens. It really works.
I didn't even know what that was. Okay, so DataBox Edge. DataBox Edge, Edge appliance, it's really about, I mean, if you take away one thing about DataBox Edge, it's about extending the Azure storage and compute surface area from inside the cloud or inside the public cloud or inside Azure Stack and extending it out to this remote endpoint, right? And because it's an Azure appliance, you manage DataBox Edge through the Azure portal. And right now, I'm remote desktoped into a server that's in my office in Sunnyvale, California, and I am managing a DataBox Edge demo device. And here it is right here, and you can kind of see we've got a bunch of shares created on this device, and we've got an Edge compute module running, which is called ML demo. You can set bandwidth policies. You can set, bandwidth. Why would you want a bandwidth policy if you want the data to trickle the cloud, for example, outside of business hours, right? And you want to have it restricted during business hours, as an example. And it's really easy to do things in here like create a share. So let's just kind of show you how this works. I can say add share, and I just kind of give this share a name. We'll call this like share 3. I can choose SMB or NFS. I can choose whether I want it to be a local share that's only on the device or one that I also trickle up to the cloud. I can map this particular share to a storage account. I can choose what type of data I want the local reads and writes to be replicated in the cloud to. So I can have the local files be represented as block blobs in the cloud or page blobs in the cloud, or they can be files in the cloud. I'll choose block blobs because that's the easiest. I can make it read only. I can make it read write. And I can select, for example, which users I want to have to access the share. And then basically that's it. You create a share locally. It maps to the storage account I selected. It will create a parallel container in the cloud that's the same name as the share. Reads and writes that happen to the share locally will also happen in the cloud. It's really, really simple, right? You don't need to, in this way you can sort of cloudify sort of any application that knows how to talk SMB or NFS, as an example. I've already created a bunch of shares here. I mean, it takes a few seconds to create a share. But let me, for like the cooking show demo, let me actually show you ones that I created here. So just to orient folks on the screen, I'm using Azure Storage Explorer, and I'm connected to the storage account that the DataBox Edge machine was connected to. And I have I'm browsing to a DataBox Edge device here, and I have a demo share. This is a demo share on the DataBox Edge device, and then these are just like some local files on the local machine that I've got here, right? And so really simply, for example, I can go into the gateway folder here, and I can copy a bunch of these images, and I can just kind of copy them up into this demo share location. That's moving the files from the local server that I'm on and copying them literally just onto an SMB share. And then as soon as the copy happens, these will start trickling up to the cloud, right? As long as I've got the network bandwidth. If I don't have the network bandwidth, they'll just kind of sit there, and then when the network bandwidth comes up, they'll start to work. And so if I go over to Storage Explorer, and I go over to Demo Share here, which had nothing in it, and I hit refresh, and the demo gods are working well with me, I should start to see these files actually appear in the cloud, right? So really simple, just copy the files locally into a share, and they all just kind of go up into the cloud. That's what a gateway does. It's what a storage gateway does. But let's get a little bit more sophisticated, and let's see if we can actually bring the compute into the demo as well. And so I have another share here. I'm going to minimize a couple of these windows and bring a couple new ones up. And let's see, I have an input share, an output share, and let's go back here. Okay, so now, next scenario, I'm going to get a little bit more sophisticated. And what we did before the show started is we walked around the convention center and we took some pictures of just sort of the outside of the convention center, because we wanted to sort of fabricate this scenario where we had security cameras that were dumping their pictures and videos and things like that onto DataBox Edge, right? So step one of the demo was, well, instead of storing all that data locally, let's just put it up in the cloud so that we can get to it later. And that's an awesome use case. That's great. But step two is, can we start to make intelligent decisions about that data right at the edge? And in this case, what we've done is we've extended the DataBox Edge with a ResNet ML demo, which can basically do just sort of some very basic image processing, and it can identify cars, trucks, or people in the images, right? And so what we've done is we've configured DataBox Edge, and this is all programmable, and this is all like things that you as the end users can actually configure on DataBox Edge. We built a little pipeline so that when files come in here to this input share, they start getting processed by the DataBox Edge computing pipeline, and in particular by that ML plugin that I mentioned that'll actually start to do inferencing on the images, and it'll start to identify the cars and the trucks and the people in the images. And as each individual gets processed, you're going to see it's going to disappear from this input share, and it'll show up in this output share. That's how we know the image has been processed. So I kind of opened both windows there at the same time so that you could see. And this is a really simple example. And what you'll see when I kind of show some of these pictures here, like the back lot one. Here, I'll open this one up so that we can see it. It's going to take these individual pictures. Zoom out here. It'll take these individual pictures, and it's running an inferencing algorithm on there, and it's going to draw, and it's going to select and highlight all the cars and the trucks and the pictures and things like that. And if I go back and you take a look, you'll see that sort of all of these are getting processed on the DataBox Edge device. And it's kind of going through and it's drawing boxes around the trucks. Now, why would you want to do this inferencing down at the edge, like on the device, as opposed to in the cloud, right? And that really just goes back to the things I mentioned earlier, right? It comes down to bandwidth. It comes down to latency. It comes down to being resilient to somebody digging up your network cable. And it comes down to effectively using that power at the edge to enable real-time computing decisions. You know, when two driverless cars are navigating and going around and navigating through the city street grid, they're not round-tripping all that data to the cloud to figure out whether they should turn left or whether they should brake if somebody's going, you know, out if a bicycle goes out in front of the car, right? So there's real power in being able to take that outside of Azure and kind of drive it down to the edge. And what's great is you can build this kind of virtuous cycle where you can actually still, with something like DataBox Edge, you can still send all of the data up to the cloud, and you can rescore and you can retrain your model, and then you can push your model back down to the edge to make even smarter decisions. Okay, so that's sort of the left-hand side of the spectrum. It starts with Azure Sphere, which is a secure hardware, software, and cloud management service for microcontroller units. Kind of the next step up from that is IoT Edge, which is a platform that lets you build a gateway-style device in between your IoT devices and the cloud to do some processing. And that can be run on lots of different compatible third-party hardware devices. And then sort of the next rung up from that is a first-party offer from Microsoft, which is DataBox Edge. That extends the storage and compute platform out to the edge. It has a storage platform and it has a compute platform powered by IoT Edge. Okay. Back to Natalia.
Thank you. All right, so now we're going to flip over to the right-hand side of the edge. So at the right-hand side, we've got Azure Stack, and Azure Stack is a full cloud. Show of hand in the audience, how many people are familiar with Azure Stack? Almost everyone. That'll make my job easy to explain it, so that's good. So what is Azure Stack? Azure Stack is a full cloud that you can have on premises, and really it's almost any location. I don't always say data center. I think when we initially were talking about it, it's providing your cloud in your data center, but it literally can be any location. And the real value proposition is that it can provide consistent application development. So the development that you're using in Azure, you can use on Azure Stack because it is the same cloud. We use the same control plane, the Azure Resource Manager, so you can have consistent lifecycle management of your applications and services and use the same development resources and DevOps resources that you have from Azure, as well as Azure Stack. The other benefit is Azure Services on premises. So this is a full cloud. Dean talked a lot about some of the containerized services. Azure Stack provides full services, and that can be everything from virtualized with infrastructure as a service to PaaS services. And the last tenet is really, it's built on purpose-built integrated systems. So we've partnered with hardware providers to validate and test the infrastructure. So you're spending more time providing value-added services and capabilities as opposed to validating and testing some of the infrastructure. So we've had a huge engineering investment to really create integrated systems. 3 tenets is application development, services available on premises, and then those purpose-built integrated systems. So we really have, if you look at the application development, it's the same tools and experiences that you would have in Azure, you have available on Azure Stack. That means you can use the same application patterns. If you're using JSON templates in Azure, you could use those same ones in Azure Stack. You can create application patterns for applications that have multiple different servers potentially, so virtualized environments. You can have the same automation and operations available with Azure Stack. The second component is the services. So today, we have many of the Azure services. This is not a replacement for Azure, so let's just be clear, because it can run in smaller environments. So we've got many of the applications and services that are available in Azure. So that does include storage, blobs, tables, and queues, as well as Key Vault for your application keys. We've got app services, so you can get up and running with web applications, and containers as well as serverless computing, so Azure Functions as well as containers. The Azure services can be first party or third party. One of the key features that I like to talk about as well is the marketplace. In Azure, you have a marketplace. In Azure Stack, you also have that marketplace. You can syndicate content from Azure down to an Azure Stack environment, but you control what is available in Azure Stack. The last component is that purpose-built integrated systems. So we have a highly prescribed application architecture for the hardware and topology, and we've created that and then worked hand in hand with hardware partners. So Dell, HP, Lenovo, which are our first hardware partners. Then we added Cisco. We worked with Intel and a smaller OEM called Wortman to have a system. And then most recently, we actually have Fujitsu and Huawei have systems available. We've invested a lot in deployment and configuration as well as update. So deploying a cloud is difficult to start out with, but the bigger task is really maintaining and updating it. This is a cloud, and as a cloud, it updates very frequently. So we invested heavily in the update technology, so it's a fully orchestrated patch and update technology, so you can provide updates and features to Azure Stack roughly on a monthly basis. Other characteristics are monitoring diagnostics as well as field replacement of parts. Now I'm going to go into another aspect is IoT Hub. An Azure IoT Hub, how many are familiar with Azure IoT Hub? IoT is one of the key components from an edge capabilities. Azure IoT Hub is available today in Azure, but it's also in development on Azure Stack for an end-to-end platform. IoT Hub gives you the capability to get bidirectional communication between your devices. So when you're looking at an IoT solution, you'll have your sensors and devices that you need to aggregate, you need to actually develop communication with, you need to actually do device authentication or security with those devices. So IoT Hub gives you the capability to do that. Today it does in Azure, and again, it's in development on Azure Stack. The key is provisioning of the devices at scale. So I think that's one of the key things with IoT Hub. The device management lifecycle is critical. So imagine if you have hundreds or thousands of devices in your infrastructure. Dean talked about refrigerators. If you've got a lot of refrigerators, might not be a ton, but you could have many smaller devices if you're looking at sensors that are available to give you information and feeds in a retail store, or sensors and devices on elevators. You can imagine there's a lot of sensors and devices. And one of the key aspects is the life cycle and management of those devices. Everything from planning, who's going to have access to those devices, to the security and provisioning, down to configuring, monitoring, and then you do have to think about how you're going to retire. So this is a continuous device management cycle where you have to look at all of your devices that are available and how you manage and operate those devices. So with IoT Hub, you have a device management lifecycle capability within those. With IoT, we have a large and growing ecosystem for IoT capabilities with Azure and then subsequently with Azure Stack. And this is everything from the system integrator. So we've been working with system integrators to create solutions that are IoT solutions with Azure IoT solutions. We're also working with solution providers, and we have a program for Azure Certified IoT, so you have certified solutions that are available. And then because the development lifecycle, you want consistency within that, you've got developer and productivity tools that are available. The last component of an edge solution is advanced analytics. And Dean talked about it a little bit with looking at the machine learning capabilities and doing inferencing at the edge. So analytics is becoming more and more important. With all of the devices and sensor data that you have, you want to make sense of the data that you have to make business decisions. So it's important to be able to train and evaluate machine learning models. So in Azure, you're going to be doing some of the machine learning training. Then you need to collect the data and then finally operationalize it and manage it. A typical machine learning workflow, you start with building a usable data pipeline. Then you need to train your models, operationalize them, and then you can get to the business insights. So here is a more, an architecture of how you might do that. So you'll have streaming data or batch data. You ingest that. The data ingestion can happen either from things like HD Insights or Data Factory, but you take all of your data, you put it into a data store then, such as Azure Blob Storage. From there, you apply some of your data science and AI models. From the models, you can actually take those into things like Cosmos DB or SQL Data Warehouse and create intelligent applications where you can get insights from all the data that you've served. This is a virtual cycle, too, because once you've scored and got inferencing from some of your data, you can actually take that data and get more insights and retrain some of your models and bring them into the applications. The benefit of this is you get more business insights, so you can drive your business capabilities. So with that, we're going to go to the common software.
Yeah, so actually I'm going to go back a slide. So you remember I said that, hey, DevOps is kind of key, but really going forward, we needed DevOps +++. And why is that? And if you think about it, DevOps is very good at being able to take human insight and turn that into code and move fast, right? So if you're not familiar with DevOps, what I like to say is at the heart of DevOps is really just two things. Do your work in small batches at high frequency and stop being a butthead to your coworker, right? Those are the two key things. Well, going forward, I think the key thing that needs to change, I think it doesn't quite do particularly well or it needs to be formalized, is this model around synthetic insights. And so it is, in fact, this workflow that I think needs to be integrated in and find a way to harmonize with the DevOps, right? To be able to just do both human and synthetic insights, to manage not just the flow of code, but the flow of data to generate synthetic insights and translate that into action. Okay, so DevOps. Okay, so when we talk about common software challenges, you hear these things. Low deployment frequency, takes a long time between an insight and actually getting that out to people. When something goes wrong, it takes a long time to recover, and that there's a high rate of failure. Okay? DevOps is sort of the key to solving these problems. Organizations that adopt best DevOps practices have fantastic characteristics. The State of the DevOps report has seen this year after year after year, where they go out and study people who do DevOps, and what they see is that companies that do this have 46 times the deployment frequency, 440 times faster time for changes. That is to say, the time between, hey, we should do this, and the time it actually gets done. 96 times faster mean time to recovery. And you might say, well, how can that really be true? And the answer is yes, it's true, because you've done work in small batches. Okay? Because you do work in small batches. When you do it in a big batch and something goes wrong, you've got to figure out what went wrong and undo that. When you make one change and you deliver that as a change and something goes wrong, you know exactly what went wrong. So you know exactly what to undo, and therefore you can get back to work faster. That's why these numbers sound incredible, but they are real. And you get 5 times lower failure rate from your changes. So this is all great engineering, but the money is this. that companies that have done DevOps get 20% increase in revenue, 20% faster time to market, that faster efficiency. And of course, these are self-reporting numbers. Your mileage will vary. But the key thing that is undisputable, that is that the people who are doing DevOps better than the people who aren't do see business advantage from it. So you definitely want to adopt DevOps. And DevOps is the future, the pathway to intelligent cloud, intelligent edge. So you can do DevOps today, and that gets you on the path to implementing it for this new world. So we have renamed some products and have a new initiative called Azure DevOps. Used to be Visual Studio Team Services. It has a bunch of great tools there that are very, very easy to get up and go running with. I've often done a Azure DevOps demo, and we call that the 0 to hero in 5 minutes demo. I mean, it really is that simple. So we have Azure Boards that helps you manage your work, Azure Repos to store all your source code, Azure Pipelines. I think we just announced at the show. You should check it for the details, but it's basically like we'll do your builds for free when you're storing your stuff in Azure Repos. So great stuff there. Azure Tests and Azure Artifacts. And the thing about these is our vision for the Azure DevOps tool chain is that for each of these environments, if you have your favorite tool of choice, we will integrate it into our pipeline. However, our tools are they're loosely coupled but tightly aligned. When you decide to use all of our tools, they all tightly align, and that's where you get the maximal benefit. But you don't have to. You can pick the favorite tools of your choice. Got to pick and match. Two great tools that we have to really, come up to speed with on this new intelligent cloud, intelligent edge are the intelligence tools. So, one of the challenges that we have, and I think Microsoft's really kind of leading the way here, is how do we take AI out of the worlds of the professors and the PhDs and deliver it to the common developers, right? You shouldn't have to have a PhD to do AI. And so we have great tools in this area. One of them is the Azure Machine Learning Workbench, and the other is the Microsoft Cognitive Toolkit. If you saw my show last night at the Mechanics, we showed using a PowerShell script, I was able to use the Azure Machine Learning, actually it was the Azure Anomaly Detection API, REST API, to do some fantastic processing. So you just access this via REST API, no PhD required.
Okay, so recap. If you look at what you just saw from all of us, you saw the whole continuum and spectrum of products and services that we have available for the intelligent edge. And that goes from the Azure Sphere, which is the MCU, giving you security at the device level, all the way through some of the IoT edge and data box edge capabilities that we have through a cloud. Again, it gives you consistent security, identity, management, a lot of the machine learning AI that we showed as well for the machine learning models. Our portfolio of applications and services really gives you a very comprehensive solutions that you could work on to provide your edge requirements. So I'm going to go through and give you a demo on a solution for optimizing healthcare that shows you the entire spectrum, or at least part of the spectrum, for our edge solutions.
Can I make one point before we get to the demo?
Yeah.
Go back one slide. I really do want to highlight this thing. Microsoft is your partner in your journey to the intelligent cloud, intelligent edge. Our mission is to empower you and your company to achieve more. We are not successful unless you're successful. So what does that mean? When we think about the platform, we think about the entire chain of platform, the entire flow from development to deployment, the entire integration of your developers and your IT. So we're going to deliver the entire solution, the entire platform for you so that you can be successful. You're going to hear a lot about intelligent cloud and intelligent edge going forward from the competition. you are not going to hear that story. When you hear that story, you're going to hear, I've got this great component, and what you should hear is, and you're going to need a rabbit's foot to do all the systems integration to try and make a solution work. We are going to do that systems integration for you. So we're going to be your best platform on this journey.
And to add to that, I think we're going to be your partner, but we're also working with other partners, so you could actually create solutions. So the ecosystem is equally as important in having solutions available for you. But Microsoft has invested across the entire spectrum of products for the edge, so you can be successful. So I'm going to do a demo for you now that ties together some of the components that you saw today. It really is around optimizing healthcare. And let me tee up the scenario because it gets complicated when you're talking about all these different edge capabilities. As you can imagine in healthcare organizations have to manage multiple hospitals and clinics. Within those clinics right now, here in the States, it's getting around to be flu season almost. And we've had challenges sometimes with vaccinations. And vaccinations where you can go to a clinic and all of a sudden there aren't enough vaccines available. In each one of the clinics, what happens today is clinicians oftentimes have to work on and look at their materials management. So they have to manage their inventory of supplies. They're often not trained to do that, but they have to manage those inventory of supplies. So you end up having situations where one clinic may not have any more vaccines left, where another clinic may have a surplus of them, and they have no way of understanding and talking between the two and understanding where they are. We want to make sure in this scenario, it's really about freeing up clinicians' time so they can actually spend their time on things that they need to. So the nurses can be focused on patient care. Doctors can be focused on patient care as well. So in this demo, I'm going to show you a scenario. Did I get the right one? No? 8. Sorry. So in this demo, I'm going to show you a scenario that uses DataBox Edge at the clinics. And in the clinics, you need to do real-time processing. You want to understand some of your materials and understand, in this case, it's medicines and vaccines. Today, nurses have to actually manually understand what's available from a supplies perspective. They also have to start looking at heat capabilities and others that drives half-life of some of the medicines. So here in this demo, I've got a DataBox Edge, as you can see, DataBox Edge. And we're going to simulate some camera data that's available for that clinic. And for the data from the clinic, it's going to take pictures with looking within each of the clinics on some of the medicine. And here we have not that one. Here we have a supply, refrigerated medicines and vaccines that are available. Normally, a nurse would have to continually check, look at some of the medicine that's available, and understand iMovies, apparently, too. Look at some of the medicine that's available and do that manually. With DataBox Edge, we're doing through a machine learning model, we're actually doing scoring at that refrigerator and looking at specifically, with that machine learning model, looking at what is available. So you can look at some of the tags based on and the weight of the medicines to understand if they have stock available and if it hasn't expired, if you can move it potentially to other clinics. From a clinician perspective, an application, you'd have a supply room application for materials management. Here you can see that scored video, scored image that came in from the clinic. It'll also take in data from other sensors. The sensors could be the temperature, it could be humidity, could be UV capabilities. All of that impacts some of the medicine and vaccines that you might have available in your actual supply. So based on that, we can see here that temperature might be a little high, so it might be impacting some of the medicines you have. And you want to look at what your action plan would be across the entire health system. So if I go to my action plan, through machine learning models running on Azure Stack, you can see that there is an action from the Northwest Clinic to move flu vaccine to a few other clinics. So they had a surplus of flu vaccinations, and they're going to move it to other clinics that don't have that vaccine available. So how is this done? Here, if we look at in this is Microsoft Azure Stack. You can see it here. The portal looks exactly the same as Azure. But within this clinic, we're running Azure Stack because of the processing that needs to be available, as well as within that healthcare organization, some of the regulatory requirements that they have to have some of the data. So this is a full end-to-end IoT solution where we have a clinic IoT hub that's running. So IoT hub is running. We can take data from the DataBox Edge devices as well as from other sensors to make real-time analytics, stitch all of that data together and do analytics and know when to actually move vaccines. Within the IoT hub then, you'll see we have additional devices, so we're getting data from each of the different clinics that have DataBox Edge. So again, that is one solution where you can take both the device and sensor data as well as data that's being real-time processed from DataBox Edge and bring it into IoT Hub on Azure Stack. As you can imagine, in a hospital, in a healthcare system, again, it's life and death in a hospital system. So if you have a disconnection, latency in the network potentially, you want to make sure that you can make these decisions real time. Okay, so that is the demo. Thank you. And let's go back to 5. So if I look at the demo architecture that I showed you, here we've got a device network, and I think this is really important to understand. You want your devices potentially on a separate network. Those devices can be communicating to an IoT Edge. In this case, it's a DataBox Edge that has IoT Edge. And then it also can do some of the machine learning with brainwave FPGAs. You want to separate your device network potentially from your medical network. So the medical network will have more of your applications and services, as well as some of the clinicians accessing the medical network. On the medical network, we also have then Azure Stack running with IoT Hub. And IoT Hub then can take event hubs and stream those to Azure across the internet. So within those different aspects, you've got your, again, device network, medical network, and internet. And with each of those, you have the capability to do some of the inferencing, aggregate the data, and transmit it to your systems of record, integrate with your systems of record, and then also go into Azure for some of your deep learning and training your models. We won't have a lot of time to go through the architecture, so I'm going to go very quickly, but we'll post this deck so you have it available. This is the architecture that made that possible. You see there's devices, the DataBox Edge, Azure Stack, DevOps for the developers, as well as Azure. There's different personas when you're creating these types of systems. So in a solution that takes a lot of data analytics from multiple different sensors and devices, you do want to have data scientists and data analysts. You'll also have the developers creating some of the models, and then the end users accessing some of the insights. At the Azure level, so this is public Azure, you do need to start looking, that's where you can train some of your models. Some of the key things you need to think through are what types of models do you want to have for data models? What are the data sources going to be? Where are you going to get data from? Is it just from sensors or devices? Is it from your back-end legacy systems or systems of records? And what is the scale that you need to have available for those systems? From a devices perspective, you need to have a sense for how many devices are you going to have. Again, it could be hundreds, it could be thousands, could be tens of thousands, depending on what type of infrastructure you're building. More and more, we're seeing in each industry and vertical, we're seeing that people are adding devices and sensors so they have real-time data that they can have. You want to know what type of data there is being received, and then the storage requirements. Based on the data you get from sensors and devices, you need to know how large of a storage queue you need to have. And then finally, the network and bandwidth considerations. How is this going to impact your network? And that's with DataBox Edge too. Sorry, it's not just the devices, DataBox Edge. The next thing you need to look at is on Azure Stack. Azure Stack will take the data and aggregate it from, again, the scored data that you've had from DataBox Edge, as well as devices and sensors. Here you can integrate with back-end systems. For instance, in healthcare, a very popular back-end system is Epic Healthcare. It could be Cerner or others. So you're integrating with legacy systems. Again, you have to look at what is your network and bandwidth, and what are the applications and services that are going to be using the data. And then finally, the developers. You need to look at, the developers need to understand this is not code that's written once. It needs to be maintained. What are your CI/CD pipelines? How do you manage the code? When is it going to be released and how often? And where do the applications need to run? So these are the high-level architectural considerations. And I know I'm over, so I'm going to let Jeffrey. What? Oh, yeah. Let Jeffrey finish this. We're over already. I'm going to let him finish with this slide because we're over. But we do have, since all of you came and spent time with us, we've been each given one drone to give away. So we're going to ask some questions. We'll do some bingo, see if you remember what we said.
Okay, so quickly, when you develop these new systems, it's important to think about the full life cycle or the full set of concerns. What are the business concerns? What are the technology concerns? And then what are the societal concerns? I think tomorrow I'll give a talk, software development in the age of social responsibility. I encourage you to come to that. I drill into this into great detail. So this is all about amplifying the entire range of your business, all elements of your business. Here's a number of different examples. I'll leave you to read these from the deck that we've provided. But it also amplifies all the industries, right? We've talked to lots of industries. And this intelligent cloud, intelligent edge pattern is resonating with each one of those industries. So we're very excited about this. As you pursue this, as with each of the previous paradigm changes, you know, we said mainframe to PC to cloud, or systems of record, systems of communication, systems of engagement. Jobs change. Jobs change, and so too intelligent cloud, intelligent edge jobs will change. We think that there's a pretty good mapping. Microsoft is dedicated to help you figure that out. So we have a roadmap for people. Here's a roadmap for people in Azure and Azure Stack, a set of learnings, a set of trainings, a set of certifications that you can go pursue. And here's sort of the takeaway. First, roadmap for progress. Admit that you have opportunities and that you have problems that need to be solved. This is a company-wide thing. It can't just be done by development. You need the business people, you need IT people, all working together to move the ball forward. Key to all this stuff, whether it's DevOps in general or intelligent cloud, intelligent edge, is set small goals. Get some success early on and then grow. Do not try and big bang it. Try and do it all at once. Those are ways you fail, and if you fail, it'll be difficult to try again. Start small, fail small. Start small, fail small. Then learn and iterate. And that's why you work in small batches.
Okay, you can ask a question, because we are already way over, so thank you those of you who stayed. I'm going to let Jeffrey ask a question, first person to answer it correctly.
Yeah, you got to raise your hand, and I'm going to call you, and this shows the benefits of having sat up front, because I'm going to call the people up front first. Who said the future is already here, it's just unevenly distributed? First row. Oh, we got a winner. William Gibson. Pretty cool drone.
Go ahead, Dean.
Cheers.
Okay, I'm not that clever. What type of compute engine runs on DataBox Edge? I saw this hand first. Gentleman with the glasses? Not broad enough. I'm not going to accept that. Over here? Not SphereOS. I need a better presentation. What compute engine runs on DataBox Edge? Azure IoT Edge. That is the correct answer. Woo!
All right, I'll make mine easy. Azure Stack. We have many hardware providers available. Name 3 of the Azure Stack hardware providers. I don't know, everyone's hand went up at the same time. I think I saw yours first in blue. And those were the very first. Congrats. I'm going to let somebody else take them because it's hard work. Thank you. Thank you, everyone.
Thank you, and have a great Ignite.